Hi guys, now in this video we're going to be going through how to do this using your graphics calculator. So the first thing is you need to be able to put this information into your graphics calculator, and I'll show you how to do that. Now obviously there are instructions of how to do that. So the first thing is, from your screen, if we just go to our screen here, we have to press the Stat button, and then we're going to go Edit, because Edit's where we put in things. Alright, so now you may have some things in your columns there. See how I've gone up and that's highlighted up there, it's black. If I go clear, that's going to delete everything. Alright, we go again across and we go up to the black bit and we go clear, then that is how we simply clear quickly a column. Now all you have to do is simply go and put your data in, just type it in. If I go there, I made a mistake now, that's not supposed to be 14, come up here, I can go 1.4, I can enter the data. Now just to save some time, I've already done that. Now, key thing over here is we can now take the log of list number 1. So we just press log. Now the blue button, second function, allows you to get the little L1 there. Right, and then we go enter, that will do all of the L1s for us. Go across up here, and we're going to do log of list number 2. So therefore, if we do that, that will give us our second graph, which is, so I press log in here, log and list number 2. I've now calculated the logs of each of these things here. Come back to our question and we'll just put down what we've got here. Alright, so in our thing over here, so we have, if we start looking at our pen, alright, so when we're looking at here, this is in fact list number 1 and that's list number 2. So when we start looking at log of D, then that is list number 4, and we know that log of T is list number 3. It's probably easy to write like that. So that there, this one is T and that there is D. Alright, so when we do our calculator stuff over here, you're going to need to remember that. So we're going to go back to our calculator. Right, so we're going to graph this data, and the first thing I suggest you do is clear any graphs in your y-axis bit. Alright, so the next thing we have to do, we have to go up to stat plot. Now most of these will be off most of the time, but you come in here and you click and you go on. Alright, and then if we do list number 1 versus list number 2, alright, that's going to be putting X, the time, on our x-axis, and I'll put our D value on our y-axis. So if I graph that, okay, now your graph might not look like that all the time, so what I suggest you always do is go zoom 9, and that will do the graph there. Now you can see it's not quite a linear graph, it's sort of like an exponential graph. Alright, so that's what we're expected to do. Now the instructions are, can you please do a graph of log D versus T, and can you do a graph of log D versus log of T? Alright, so that's what we've been asked to do. So log of D is our y-axis. So we come back to our second function. Remember, log D is in fact going to be our list number 4. So I have to change that to list number 4. Alright, enter, and we're going to graph that. Now again, we use zoom number 9 or zoom stat, and so what we can do is we can take a screenshot of that, capture screen. I'm going to copy that, copy, I'm just going to paste that in there. That's our first graph, and then what we're going to do is we're going to go and do our second graph. So come back to here, we're going to go y equals our stat plot, go in here, and our second graph is in fact making the log of t. All right, so that was in fact list number 3, if you remember from what we were doing before. And if I graph that, well, we don't see that, so remember we've got to go zoom 9, and that will give us that. Now that quite clearly looks like a linear graph. Okay, again we'll take a snapshot of that. We'll copy that, and then we'll paste that into our Word document in there. And that's the 2 graphs that we've got. Now one looks more linear than the other one. Now the key thing is what we need to do is we need to get an idea of what the equation is. Right, so on here our calculator does this for us. So if we go to calc, we can do a linear regression over here. All right, and remember the one that we're looking for is list number 3 and list number 4. So that's what we're going to put in here. And come down here, we're going to put in list number 4. Right, and then what we're going to do is we're going to, and this is a bit clever, we're going to put this into our graph. So remember, we go vars, we go to y vars, we go to function, and we go y1. What that will do, will store that value in our y equals, and then we'll better graph that. Again, I'm going to take a capture of that. Copy that, and I'm going to paste that into my Word document as well, because that's some evidence that we've got of our actual equation. Right, so then when I go back to my calculator, if I actually go graph, you'll see that it draws a line of best fit that goes pretty well through the axes there. All right, so as with this video, you may want to rewind parts of it because I'm going through this pretty quickly. All right, so what this has given me, if we go and do the rest of this equation here, old school way we used to have to do was horrendous. Okay, we've got our graph of log t versus log d. We've got an equation, and our equation goes something like this, and it's saying that our equation here is y is equal to, our slope is going to be our a value, which is 1.9677, x plus our c value, which is saying it's 0.7033. Right, so that's going to give us our equation. So when I start looking at the relationships here, our y value is in fact log d. So our log d is our equation. Our slope is 1.9677 log t, and our c value is plus 0.7033. So I need to rearrange this into an equation which relates d and t. So the easiest thing I need to do is simply now do this. Write this as log t to the power of 1.9677 plus log of 10 to the power of negative 0.7033. Then what we can say is log d is equal to log of, now we're going to use our indices or our log laws, and we're going to combine those. So that will be 10 to the 0.7033 times by t to the power of 1.9677. So because we've got logs on both sides, and this is pretty well all on the bracket here, we can say therefore d is equal to 10 to the 0.7033 times by t to the 1.9677. So then what I can do if I want to, so I can go back to my calculator, and I'll quit from there. If I go 10 to the power of 0.7 0.033, don't think there's that many threes, then that should give me a value. So that's 5.05, which is probably a better way of putting that. So if I can then write that as equal to, D is equal to 5.05 T to the 1.9677. So that's given me quite a good equation relating those values. All right, so that's really, really fantastic how I can use my calculator to get that in that form. Now, the other quick way, and I'll show you the new way using technology. All right, so if we've got our equation, which is generally our data, we'll start with our list number 1 and our list number 2. Right, so technically what I've just shown you is the old school way of doing it, but using technology to do that. What our stat button will do is allow us to, now if I just graph that, and I'll get rid of my y equation, clear that. Right, if I graph that, remember we have to go zoom 9. This is our original data. So if I go to my stat button and I go across to calc, if I think that is an exponential graph, which I believe it is, what I can do is I can choose my list that I'm looking at here, and the technology will do all of that work that we just did in the background, and it will do all that work for us automatically. So we're going to put this into our Y1 again. All right, and then we're going to calculate that. It will tell us what our model is, so in the form of a, b to the power of x. So it's giving us our values, and when I graph that, you can see it's quite a good model. It's not too bad a model. If we go back to our thing over there, you could see it had a very strong correlation for those values. All right, so if I also then go, I can try some other models. Right, so I could go in here and I can go to a quadratic and see what that looks like. Right, so we can go down to and put that into our vars. And Y1, again, we're doing this so we can actually get a graph of the line of best fit. And you can see that the correlation's pretty high. So we're graphing that. It's actually not a bad representation of the data. All right. So we can try different models until we get one that we're quite happy with that. So that's probably the easiest way of doing it. I hope this makes sense. Obviously, if you need some help, catch up with one of us teachers.